Scientific records suggest that the average level of the sea surface relative to the continental land has remained relatively constant across nearly 4 billion years. This suggests a constant recycle of water emerging from and being absorbed back into the mantle. This kind of mechanism is only possible if the water was originated inside out process. This process of cycling has significantly helped life to continue throughout the history of our planet. Scientific records suggest that the average level of the sea surface relative to the continental land has remained relatively constant across nearly 4 billion years. This suggests a constant recycle of water emerging from and being absorbed back into the mantle. This kind of mechanism is only possible if the water was originated inside out process. This process of cycling has significantly helped life to continue throughout the history of our planet. Despite the presence of water vapors, oceans formed through a long and complex process. During the early period of Earth's history, there was a long period of massive volcanic eruption, thus releasing a huge amount of gases and vapors. A vast layer of volatiles accumulated gradually over the period of millions of years, continual degassing from the Earth's interior. And the Earth's gravitational force prevented these volatiles to escape from the Earth's atmosphere. The water remained in the form of gas until Earth cooled to 100 degrees centigrade, and thereafter it rained for several thousand years or more continuously. As the water drained into the great hollows in the Earth's surface, the primitive ocean came into the existence. Thus, the Earth's ocean and atmosphere formed in three major steps. Initially, there was only water vapor in the atmosphere, as air and the ground surface was too hot for a liquid water to stay. Cooling of atmosphere led to the condensation and rain. However, the ground was still hot for cooling. Subsequently, cooling of the ground surface finally led to the accumulation of liquid water on the surface. It brings another major question about the ages of ocean. Direct evidences of the existence of an ancient ocean is provided by pillow lava formed throughout the Earth's history and located in various locations around the planet. At present, it is thought that the oceans have existed since very early stage of the Earth's history. This lava is characterized by pillow-shaped masses and is found when hot lava flows into the water and cools rapidly. The oldest pillow lavas were found in the Isua supercrustal belt of southern western Greenland and were determined to have formed at 3.7 to 3.8 billion years ago. That means Earth's ocean must have existed at the age of 3 billion years. Now let's have some discussion on the quantity of water present on the Earth. Our Earth is often referred as an aquaplanet due to the large quantity of water on its surface. You might be well aware that 71% of the Earth's surface is covered by the oceans, and which is huge if we compare this with other terrestrial planets of our solar system such as Mercury, Venus and Mars. The amount of water in the ocean on the Earth's surface is reported to be around 1.4 billion cubic kilometer. Additionally, 0.5 billion cubic kilometer of water is stored in different reservoirs such as glaciers, groundwater, lakes, swamps and rivers, etc. Let's calculate the water beneath the Earth's surface now. The Earth's mantle could potentially represent a huge reservoir of water because of its large mass. And if the entire mantle contains on an average 0.1 weight% of water, it equates to about 4 billion cubic kilometer of water, which is double of all water on the Earth's surface. However, based on extensive analysis of mantle-driven rocks, geophysical probing methods, water content of mantle is inferred to be 5 times of the water on Earth's surface. Earth has held water during the magma ocean stage. A significant fraction of hydrogen in the water would have been incorporated in the Earth's core. Therefore, the core is potentially a huge reservoir of water, which may have almost 100 times more water than the oceans of Earth. That means we have huge reservoir of water beneath the surface. Now, how about if we compare the quantity of water on the Earth with other planets? The mass of Earth's ocean is about 0.023 weight% of planet's total mass. Even if the water in the Earth's interior is taken into account, the mass fraction of water does not exceed 2 weight% of the total planetary mass. In contrast, Uranus and Neptune, the outermost planet in our solar system, are composed primarily of hydrogen oxide, which makes 60 to 70 weight% of total mass of the planets. Therefore, Earth is not truly an aquaplanet from that point of view. However, strictly speaking, Uranus and Neptune are not aquaplanet either, because their abundance of H2O is not in form of liquid, but it's in form of ice.